Now we'll discuss about transformer protection. So in the transformer protection, that is falls in the transformer protection schemes of transformer, Buchholz relay, earth fault or leakage protection, and differential systems, that is mass price circulating current. So first is the faults in the transformer. So transformers are static devices totally enclosed and generally oil immersed, and common transformer faults are open circuits, overheating, winding short circuits. So open circuit faults in one phase of a three-phase transformer may cause undesirable heating. And overheating of the transformer is usually caused by sustained overloads or short circuits. And winding short circuits, also called as internal faults on the transformer, arises from corrosion of winding insulation. Protection schemes of transformers, that is Buchholz devices, that is providing protection against all kinds of incipient faults, that is low developing fault such as insulation failure of windings, earth fault relays, that is providing protection earth fault only, overcurrent relays, providing protection mainly against face-to-face faults, differential relays is providing protection against both earth and face faults. So the choice of particular combination of systems may depend upon several factors, that is size of transformer, type of cooling, location of the transformer in the network, nature of load supplied, importance of service for which transformer is required. Next is the Buchholz relay. So this is a gas actuated relay installed in oil immersed transformers. So it is used to give an alarm in case of incipient faults in the transformer. So universal practice to use Buchholz relay on all such oil immersed transformers having ratings in excess of 750 kilovolt ampere. Main construction is it has two elements. Upper element consists of a mercury type switch attached to the float. The lower element contains mercury switch mounted to the hinge type flap located in the direct path of flow of oil from the transformer. The upper element closes an alarm circuit during incipient faults, whereas the lower element is arranged to tip off the circuit breaker in case of severe internal faults. The main operation is, in case of incipient faults within the transformer, the heat due to the fault causes the decomposition of some transformer oil in the main tank. So the hydrogen gas being light tries to go into the conservator and in the process gets entrapped in the upper part of the relay chamber. So the oil in the main tank rushes towards the conservator via the Buchholz relay, and in doing so tilts the flap to close the contacts of mercury switch. So here is the diagram of the protection of the transformer, which has alarm circuit, mercury switch, conservator, and the two trip circuit. Main advantage is it is simplest form of transformer protection. It detects the incipient faults at the stage earlier than if possible with other forms of protection. Disadvantages is it can only be used with oil immersed transformers. The device can detect only faults below oil level in the transformer. Next is the earth fault protection. So an earth fault usually involves a partial breakdown of winding insulation to earth. The resulting leakage current is considerably less than the short circuit current. So under these circumstances, it is profitably to employ earth flow relays in order to ensure the disconnection of earth fault. Next is core balance leakage protection. So under normal conditions, the vector sum of three phase currents is 0 and there is no resultant flux in the core of current transformer, no matter how much the load is out of balance. So here is the core balance leakage protection circuit, primary, secondary transformers, current transformers, primary and secondary winding, relay circuit, and to the trip circuit. However, occurrence of earth fault, the vector sum of three phases currents is no longer 0. So this energizes the relay to trip the circuit breaker and disconnect the faulty transformer from the system. Next is the combined leakage and overcurrent overload protection. So here the core balance protection described above suffers from the drawback that it cannot provide protection against overloads. So if a fault or leakage occurs between phases, the core balance relay will not operate. It is usual practice to provide combined leakage and overload protection for transformers. The earth relay has low current setting and operates under earth or leakage faults only. So the overload relays have high current setting and are arranged to operate against faults between the phases. So in the system protection, two overload relays and one leakage or earth relay is connected. So this is the combined leakage and overcurrent protection diagram. So the two overload relays are sufficient to protect against face-to-face faults. The trip contacts of overload relays and earth fault relay are connected in parallel. Therefore, with the energizing of either overload relay or earth relay, the circuit breaker will be tripped.